All right. So what we're going to do today, we're going to take a look at section 11.3. And we've got really kind of a bunch of ideas in this section. We're going to talk about one way of computing finance charges with something called an average daily balance. We're going to be taking a look at what APR is. And APR is kind of it can be kind of complex. It doesn't quite go into all the detail in the textbook what it is. I've got a website I pulled up that I think sheds a little more light what APR is. And then we're going to work more again with some formulas. Those complicated formulas I warned you about, those are coming. We'll have some problems with those. We're trying to compute monthly payments. And then we're going to take a look at, let's see, given a monthly payment, what's called an APR loan payoff formula. Excuse me, so we're going to take a look at some of those things. But let's jump into the finance charges. So this is something, say, if you miss a payment. So that's what this could be, like a missed payment. Is something like that. So what we're going to look at here is we're going to compute how much should this fee be. How much should this fee be? And the way this works is we're going to estimate the fee based on what's called the average daily balance. Excuse me. And so the idea of the average daily balance, and I'll abbreviate this as ADB. The way this works is we're going to take the balance on each day for a month. So say a 30-day period, and we'll add up these balances and divide by 30 and get the average daily balance. So let's say we have something like this. Let's go with say April 10 to May 9th. So this is going to be 30 days. So let's say from April 10 to, let's say, see here, let's go April 19. Let's go with say the balance is $100. And then let's say from April 20 through April 30, April 29. Let's say the average balance, let's say the balance each day is $150. That will go 200. We'll keep the math easy. And let's say we go April 30th and let's say May 9th. We'll say it's $300. So what we've got is this. If we take a look at this, we've got 10 days, 10 days, and 10 days. So a little trick we're going to use is this. Again, for every day, we're going to take the balance and then we're going to add it to the balances for all the other days. So you take the balance on April 10, which is 100, add that to the balance of April 11, which is also 100, add that to the balance of April 12, which is also 100, and so on. Now, there's a quicker way of doing this. So for example, what we could do is this. Instead of adding up the balance for April 10, 11, and 12 individually, we could just simply say this. We'll take the $100 and we add that up 10 times, one for each of these days in this period. The easier way of doing that is just multiply by 10. For this one, we'll take the $200, multiply by 10 days, and then we'll take the $300. We'll multiply by 10. Then the total number of days, 30. 10 plus 10 plus 10, that gives us 30. So what we've done for each day, there's a balance, and for all 30 days. So it means we have 30 balances that add up. But this is sort of a shortcut. We have 10 balances that are $100 each day. Just do it 10 times 100. You get the same result as adding 100 up 10 times. And instead of adding 200 up 10 times, just multiply by 10. Instead of adding 300 up 10 times, multiply by 10. So this will be 1,000 plus 2,000 plus 3,000. Divide by 30, or 6,000 divide by 30, and that comes out to, let's see, $200. So this would be your average daily balance. It's going to be $200. So what do we do with this average daily balance? Well, this is what we actually use to compute the fee. So like if we're late on making this payment, we're going to make the payment at the end of this monthly period. Then what we're going to do, they're going to charge the fee based on how much money we have in our account. And on average, we've had $200 in the account over a month. Sometimes it was 100, sometimes 200, sometimes 300, but on average, it was 200. And so on that average amount, we're going to use that to compute the fee. And the formula we're going to use to compute the fee is going to be our interest formula for simple interest. So I, that's going to be really for our fee, is the principal times the rate, in this case times time. Now for us, time is going to be one period. So P is going to be our average daily balance. T is going to be one period. And an R, let's get an R here. It's still being called an interest rate. So let's say we missed a payment and we're going to be a month paying it back. And so what they're going to do is they're going to calculate the average daily balance. And then let's say the fee rate is going to be 1.5%. This is for one period. So what we'll get so let's say the fee say it's 1.5%. So that means our fee is PRT, or for us it'll be that average daily balance of $200. And then times 1. Let's check one thing. And this will come out to $3. So that's going to be our finance charge. Now I'm looking for a little bit of justification for your T being 1, other than just being part of the formula that they're using. And let's see. I want to say it's because it's one cycle, one period, but they're not actually saying that. So let's back off from that. Let's just go with it being 1. Let's just call it 1. That is the way that they're doing it. So we'll just leave T as 1, sort of like what we did for, let's say we were calculating effective interest rates. We let T just be 1. So we're going to do the same thing here. So any questions about that? All right. So the next thing to talk about is APR. And it's just my opinion, but I think they're a little vague about this in the text. So for APR, it's your approximate annual percentage rate. So one of the things to kind of look at with APR is the difference between APR and simple interest. So let me pull up a little website here. And this comes from, let's see, pull this up. It's just here. But there's a little more to APR. Let me see, let me pull up my search real quick. There it is. So where I'm pulling this from, so I'm going to just give the source of where this is coming from. But this is a definition I've heard for, or an explanation I've heard before. But what this website is saying is that the APR is the total annual percentage rate. This is the rate that can be used to calculate the cost of the loan, taking into account, here's the thing, the reducing balance of the loan amount expressed as a, ooh, where'd it go? That's not the one that I saw, sorry about that. Oh dear, there's a really good explanation that was here, I apologize. Ah, better source. All right. Clicked on the wrong one. I accidentally closed the window when I found it, and I was just like, argh. Or absent-mindedly closed it. So here's this one. So this is the definition or explanation I remember from last time we looked at this. So consumerfinance.gov. So let me give you this one, consumerfinance.gov. And so what they're saying is annual percentage rate, or APR, is a broader measure of the cost of borrowing money than the interest rate. Now we're going to talk about this when we get into mortgages. But the APR reflects the interest rate. Any points, now points are going to be fees that are added to your loan. So when you take out a loan, you're not just going to be borrowing money that you're going to have to pay back. You're not going to be accruing interest that you're going to pay. There are also handling fees that go with it also. So it reflects, the APR reflects the interest rate, points, which are a type of fee, mortgage broker fees, and other charges that you pay to get the loan. For this reason, your APR is usually higher than your interest rate. So basically, you can have the simple interest rate. It includes the interest rate and fees on the loan. One possibility, and let me just preface this as coming from someone who knows almost nothing about finance, but I've read in other places where you could have a really low interest rate. You're like, wow, this is a bargain, this is great. But there's a ton of fees attached to this loan. And so by the time you actually pay all these fees, if you, instead of paying the fees, let's say we converted those fees into interest, you were paying this amount of money as interest instead of fees, well, that would actually bump up the actual interest rate. So it makes the interest rate actually higher. So one of the things that, from what I've read, is you want to be careful of this really low interest rates. Like, this is great. But then you can have these really high fees. And some of these fees, especially when we get into points with mortgages, they're fees based on a percentage of the original amount of money that you borrowed. And so one of the things that they talk about in the textbook is that APR is an interest rate based on how much money is still needs to be repaid. It's like, well, how is that significant? And the idea is that if you're paying points, points are fees based on the amount of money that you've borrowed to begin with. And usually a point's like, it's like a percent, I think is what it is. But if your point fees are really high, it's almost like having a high interest rate if you were going to take those point fees and pay them off not as fees but as interest. So the idea of an APR, and those fees are based on the money, the amount of money you borrowed at the beginning. So while interest rates are affecting how much they're going to be charged against how much money is left at a given time, the point fees that could be in an APR, those are based on the amount of money that you borrowed to begin with. And that could be substantial. We're going to do an example here where you're going to see a 10% interest rate, which is okay, it's kind of high, but the APR is going to come out pretty surprising. And again, it has to accommodate all these possible fees. So that's why APR is important. And if you want to think sort of financially defensively, a low interest rate doesn't always mean you're getting a good deal. There could be a bunch of fees based on the amount of money that you're borrowing at the beginning. They could be very high, surprisingly high. So let's take a look at this. Let's do an example. Well, first, let me show you the formula. So the formula for APR, to compute APR, it's going to be something like this. It's a plus 1. For R, and let's see, R should be your simple interest rate. And N should be the number of payments. Let's double check that. Number of payments. So this is over the life. And let's say we're talking about a loan here. Life of a loan. Now, to be honest, I'm not sure exactly the mathematics of how they come up with this formula, but this is going to be an estimate. And notice it doesn't involve the amount of money you borrowed. So we're just concerned about two things: the interest rate, and then how many payments you're going to make on this loan across the life of the loan. So let's say we have this. Let's say we have a loan at 10% simple interest. And we're going to make, say, 6 payments. Let's say we're going to find the APR. So according to this formula, we're going to take our 10% interest rate and our 6 payments, and we're going to find out what this annual percentage rate actually is. And we're going to compare that to the simple interest rate. So let's see what this is going to be. So APR, approximately 2 times 6 payments. And again, we want this in decimal form. So 0.10 or 0.1, we'll say 0.10. And then 6 plus 1. So again, you want to be kind of careful here. We'll have 12 times 0.10 over 7, or 1.2 over 7. And let's see here. This comes out to approximately 0.171. Now again, this is a percent. It's a percent in decimal form. So this means the APR is going to be 17.1%, clearly higher than the simple interest that was 10%. So something to keep in mind. So questions about that? All right. So that's the situation with APR. Now, we're going to go a little farther into this. We're going to take a look at some APR formulas. And these are going to involve not just simple interest. We're going to be looking at it should be compounded interest. or an annual interest rate, and it doesn't say they're limiting themselves to simple interest, and they probably shouldn't, because we're dealing with compounding now. We're going to have our N, and N, let's see here, N should not be, let me double check. Oh no, it is the number of payments per year. So we are going to be doing, again, payments again. So we'll take a look at this. Now this is a complicated formula. So the APR monthly payment formula, this is one of these formulas when you do the calculation, you want to take your time. So the monthly payment, that's what this is going to stand for. The PMT is our monthly payment. Well, this will be A times, we'll go over what these mean. T. So we're trying to figure out what your monthly payment's going to be. So R, it's familiar, that's our interest rate. And in this case, it's not going to be the number times compounding, it's the number of payments per year. And then T is the number of years. Again, this is usually going to be the life of the loan. So one of the things you're going to be looking at here, if you borrow a certain amount of money, you're making so many payments per year for how many years? Well, what's your monthly payment going to be if it's say monthly or whatever the pay period is going to be, or the payment period. A, this is the amount of the loan. So you borrow a amount of money. You're going to be making so many payments per year for so many years. And there's going to be an interest rate. It's going to be R. And so what we're going to try to figure out is what is the payment per pay period. So typically it's monthly. It's typically monthly. And so that means that your N is going to usually be 12. So, well, if it's monthly, it has to be 12. So let's take a look here. I'm going to pick a problem from the homework set. So let's say you have this. Let's say you have a telescope. Kind of a nice telescope, $1,249, including taxes. So put in your sales tax in there, that's what the total is going to be. And let's say you do this. You purchase it. And let's take a look here. In this case, we're going to be financing it. So basically a kind of credit purchase is what we're doing. We're going to purchase it or finance it, in this case, for 2 years. And let's see, at an annual percentage rate of 12%, I want to find the monthly payments. So this telescope sells for $12.49. We're going to purchase it or finance it, in this case, for 2 years with an APR of 12%. Find the monthly payments. And you'll see deals like this sometimes, like on Amazon. I think if you go to, I want to say, well, I better be careful. I don't want to say anything not correct. But you can find online stores where you can finance your purchases. And like this. They'll tell you, so you'll see that little box that says you can purchase this making $25 payments per month for, say, 2 years or 18 months. So we want to find the monthly payment. So we're going to use our payment formula. Let me double check, make sure I didn't miss anything, because this is a complicated one. All right, it looks good. So in this case, our A will be $1,249. Again, that's the price plus the taxes and everything. The R, we make this into a decimal, 0.12. N, well, this is monthly, so that means 12. N is going to be 12. And for how long are we going to do this? Time T is 2 years. So we're going to replace these variables here with these numbers. And when we do the computations on this, we're going to be really careful. Definitely a kind of divide and conquer approach, as they say. So we have 0.12 divided by 12. And then we have to the minus nt. So we have this minus sign here. And it's going to have that 12 times our 2. Now, what we want to do is let's kind of take this thing apart a little bit, or at least approach it part by part. So there's some computations we can do. We can figure what 0.12 over 12 is, and then we can do negative 12 times 2. So 0.12 over 12. .01. And then negative 12 times 2, negative 24. And so what this means we're going to get something like this. So again, we just want to be careful. We want to go stepwise. If you're writing these steps out, if you have multiple steps, that's okay. We can take this to this point. And at this point, we've got a number and a number for our base and for our exponent. We can actually compute this exponential expression. So 0.01 power negative 24. So we're going to get this. And with this result, we're going to use as many decimals as we can. And so this is what we're going to get for 1 1/100th raised to the negative 24 power. So we'll do this subtraction. Again, I'm using as many decimal numbers as I can. Okay. So I divide this by that, this. And finally, we can do this multiplication. And this will give us the monthly payment. If I'm racing too fast, let me know. So what it comes out to So we're going to round this off to the nearest hundredth. And this is going to be our monthly payment. Now, throughout this calculation, you saw me use as many decimal spaces as my calculator would let me use. And for these types of problems, we're going to do that. There's one exception, and it's going to be this sort of part B. How much is paid in total over the life of the loan? So the way we're going to figure this out, we have the amount per payment. And so what we need are the total number of payments. And then we multiply the total number of payments by what we're paying per payment. And that gives us the total amount of money that we've paid over the life of the loan. So total payments. This is going to be N times T. So the number of payments per year times the number of years. So total times 2 or 24. So total paid will be PMT times total payments. Or in this case, 58 point, and here's the key thing. this is a time when we actually don't use the non-rounded version. When figuring this out, we'll take the payment that we computed in the first part, the rounded version of it. We're going to use the rounded version of it. So take 58.79 times 24. And what we'll get is $1,410.96. So that's how we figure out the total that was paid over the life of the loan. Part C, a last thing. How much was the interest? So to figure this out, what we're going to do, this is how much we paid over the life of the loan. So we're going to subtract from this the amount of money we actually borrowed. So we're going to figure this out by taking the total paid minus the amount that we borrowed, which we can still call the principal. So this will be $1,410.96 minus, let's see here, $1,249. That comes out to $161.96. So that's how we figure out the amount of interest that was paid. Questions about that? All right. So the last thing to mention in this section, so we can compute the monthly payment if we know how much we borrowed, the interest rate, how many payments per year, and for this one monthly it's going to be 12, and then for how many years we're going to be trying to pay this back. So now we're going to ask the other question. If we know the monthly payments, well, what does that mean in terms of how much we're going to pay? And so this is what we call a payoff. And so what we're going to try to figure out here, let's say we've been making payments on this loan, and we decide, you know what, I just want to pay it all off right now. So based on the number of payments I have left, what am I going to need to send in to pay off this loan? So it works like this. So how much is needed to pay off loan when there are still payments left? So we're not talking about paying off the loan at the very end of the period where the borrowing period is ended. We're talking about like we're in the middle of that borrowing period. We say, hey, I just want to pay it off right now. That's what we're going to try to figure out. How much is that going to be? So the formula is going to be this. It's very similar to the other one. All we're doing actually is we just take this piece, we divide it onto the other side to get the formula we had from before. And use some algebraic simplification there, but this one has a slight and significant difference. So the usual variables are there. Now, payment is again, and it should still be monthly. See if they keep it as monthly. I'm not insisting on it, so I'm just going to say it's the payment you're making per payment period. So it's leaving open the possibility this might not be a monthly payment, it could be a quarterly payment. So if it was quarterly, then that would suggest that your in here is going to be 4, but it should be monthly. It should be monthly.
Is that a negative
So
U?
in, just double check, so not, yeah, number of payments. So they might change it.
Is that a negative U?
Monthly to something else. So again, number of payments per year. And A, what we're looking for is the amount needed
Is that a negative U at the top?
pay off the loan. Now, I know
Is that a
leaving
negative
one out
U?
here, but just to kind of recap. Oh, of course, we need our interest rate, leaving 2 out.
Mr. Coburn?
So we have our interest rate, number of payments per year. This is the payment at the end of each payment period. We're looking for how much we're going to need to come up with to pay this loan off, sort of in the middle or while we haven't actually finished the time period we were borrowing the money for. But there's one that I'm leaving off here. It's U. U is the number of payments left. So if we actually fulfilled the regular schedule of payments to the very end of the loan period, then the number of payments left from when we would like to pay this loan off all of a sudden to when we're scheduled to finish paying it off according to the original schedule, that number of payments, that's U. So let's take a look at an example. Let's see. Let's say you have this. So let's say you have a 4-year car loan at 7.2%. They're both monthly payments. So this loan is at 7.2%. It has monthly payments. And let's see. Monthly payments. Oh, $587 and 21 cents. So let's say after 2.5 years, you decide to pay off this loan. So what is the payoff amount for this loan? So what's the payoff amount for this loan? So again, for your car loan, monthly payments, so 12 payments per year. We've got 7.2% interest on this loan. We're doing monthly payments of $587.21. After 2.5 years, we're done. We want to just pay it all off right now. You don't want to wait for the full 4. So how much do we have to pay at 2.5 years to cover the rest of this loan? Well, first off, let's try to figure out U. So U is the number of remaining payments. All the other pieces of the formula are actually here. We have our PMT, we have our R, monthly, that's 12, that's going to be our N. We're going to search for our A, we're solving for that. Use the one that we still need to figure out. So we've got 4-year loan, but we're only going to go for 2.5 years. So years left. Minus 2.5. So 4 minus 2.5. So 1.5. So we have 1.5 years left. Now we're making monthly payments. So what we're going to have left over are the monthly payments per year for 1.5 years. So the number of remaining, so U, the number of remaining payments left will be 1.5 years times 12 payments per year. And that's going to turn out to be 18 payments. So U is going to be 18. Again, all the other pieces are there, but we did have to come up with U on our own. So let's put this all together. So you have payment times R over N, 1 minus 1 plus R over N to the negative U. 500 $87.21 times 0.072 divided by 12, 1 minus 1 plus 0.072 divided by 12 to the negative 18. So again, we want to be really careful here. 0.072 divided by 12. Let's see. 6.006. So this means 587.21 cents. 1 minus 1 plus 0.006. Then 0.006 to the negative 18. And again, just being really careful here. So now at this point, we can take 1 in 6,000ths, raise that to the negative 18. And so we're going to get a decimal, fairly long one. Again, we're going to use as many digits as we can. So we subtract from 1, we'll get this. Again, just going through these steps, another advantage for doing it this way, I know it can be a bit tedious, but if you're working on a test, for example, and you're feeling that time crunch, this is a good way just to make sure you don't miss a step along the way when that pressure is on. So this kind of helps keep things a little more organized. Though I'll admit it can get a little tedious. So finally, we do this multiplication. We're going to get $9,990, and we're going to round to the hundreds. 66 cents. And again, that's rounded to the hundreds place. So to pay off this loan, whatever this amount was, to do this a year and a half early, we need to send in $9,990.66. So any questions about that? So that's really it for this section. If any questions, let me know. Again, I recommend with these steps, go through them slowly, go through them carefully. And if any questions, let me know.